Hello everyone, very good evening and welcome to the BYJU'S Exam Prep, the most comprehensive app for all exams. Let me know that sound quality, picture quality, everything is fine. Now, we are going to start very important session for you, and that is for coming exams like what GATE 2023 and Engineering Services Exam 2023, right? So sound quality, picture quality, everything is fine. Yes, please. And now I'm going to take very common topic for electrical, electronics and instrumentation branch, and that is what network or circuit theory. And I will cover one important topic from this subject, that is what Thevenins theorem, Norton's theorem, right? Maximum power transfer theorem, maximum average power transfer theorem, Thevenins theorem, reciprocity theorem, means all the theorems. We will discuss all the theorems in this session. This is a series where we will cover all theorems with important concept, with important numericals, right? You are going to get the command over this topic. Okay, let me know that sound quality, picture quality, everything is fine now. Yes, please. And first of all, if everything is fine, then share the link of this session, like the session and subscribe our channel. Okay then. So my dear friends, this is a Thevenins theorem. We will start with the Thevenins theorem. Why? Because in every year, right, for GATE exam, this topic is very important. We are getting the direct question from circuit theory or network from this topic, Thevenins theorem or Norton's theorem, and we are getting indirect question from what? Analog also. From, for example, find the Thevenins equivalent of what? BJT, common emitter, common collector or common base configuration. Thevenins equivalent or Norton's equivalent of what? FET, common source, common drain, common gate configuration. We have to find the Norton's or Thevenins equivalent of all these configuration. Okay, so we are going to get the idea about this topic, that is what Thevenins and Norton's theorem. Now let's start, and this topic is very important, so please use your copy, pen and calculator and try to solve this question. Try to make notes, right, and these notes are very important for you. Okay, तो ऐसा पढ़िए जैसे कि आप एग्जाम हॉल में, और एग्जाम के लिए आप बहुत ही सिंसियरली प्रिपरेशन कर रहे हैं, एक क्लास अटेंड कर रहे हैं. ट्राई टू मेक प्रॉपर नोट्स, शॉर्ट नोट्स, डिटेल नोट्स, okay, and try to solve number of numericals with me. Okay then. So I think now you are ready for this session. Okay then. Now, first of all, my introduction. Give me 1 minute. Or give me suggestion at which type of numericals you want. If you have any problems in solving questions or previous year question, you can post all these questions on my Telegram channel, that is Electronics by Sanjay Rathi. Please join my Telegram channel, that is Electronics by Sanjay Rathi, right? If you have any difficulty in any type of questions from the theorems, definitely I will try to discuss those questions in my session, those topics in my session. Okay, Thevenins theorem, Norton's theorem, or what? Superposition theorem, maximum power transfer theorem, you can ask. You can post this type of questions in my Telegram channel. Okay then. 1 minute. Now this is the Thevenins theorem, and this is my introduction. Myself Sanjay Rathi. I am having 21 plus years of teaching experience in the field of competitive exams like ECE, GATE and PSU. I have qualified and selected for Engineering Services Exam, and these are my ranks: AIR 16 in ECE 2005 and AIR 21 in ECE 2008, and I have mentored more than 1 lakh students for these exams. So these are my achievements, and What about the role of the circuit theory? That is possible because of what? Command over this subject, network or circuit theory. Now, how does the GATE 2023 in first attempt, that is on 8th May 2022 at 12:30 p.m. register now on BYJU'S Exam Prep app, that is by Ashutosh Sir. Okay, so please register. Note the date, 8th May 2022, 12:30 p.m. It is a workshop and you can attempt how we can clear the GATE exam in first attempt. Okay. Now, we will start with what? Thevenins theorem. Right? Simply, what is the Thevenins theorem? Right? And which type of questions? So, in this session, I am going to cover Thevenins theorem. Right? And then with practical examples, right, with independent sources and then dependent sources. We are going to cover all this topic here. Okay, independent and dependent sources. Previous year questions. Duration of this session is around 40 to 45 minutes, and within 40 to 45 minutes you will get the command over this topic. Okay, and now it is followed by a session on what? Norton's theorem, then numericals, and then what? Maximum power transfer theorem, superposition theorem, and at the last Thevenins theorem and what? Reciprocity theorem. Okay. Now, what is the Thevenins theorem? My dear students, any network, whether it is a BJT, common emitter, common collector, common base, or any type of network, we can get a Thevenins equivalent of that. What is the Thevenins equivalent and how to solve the numericals? The Thevenins equivalent means the Thevenins theorem states that any two-terminal linear network, means normally we are dealing with what? This type of network. Right, this is called two-port network. This is called output, this is called input. If it is linear network, then we can find a Thevenins equivalent of this network. There will be one resistor, and that is one voltage source, that is called VTH. If this is the two terminal A and B, and here we are connecting the source, then this particular network can be converted into a single voltage source and in single resistors in series with this. Okay, so this VTH is nothing but VOC. This is called open circuit voltage. Right, this VTH is nothing but VOC, that is what? Open circuit voltage. What is the meaning of the open circuit voltage? If you want to calculate the VTH, then simply, if in any network, if RL is connected, make the RL is equal to infinite. Make the RL is equal to infinite and then find the voltage across open circuit terminal. That is called VTH. RTH means what is the R equivalent at this point? What is the resistance seen at the terminal A and B with active sources, that is independent active sources, equal to what? 0. For example, if this is the input active sources Vs, you have to make it what? 0, and then find the R equivalent that is seen at the terminal A and B. So that is called Thevenins resistance. Okay. Watch this diagram, watch this statement first of all, because this time we are having MSQ, multiple select question in GATE exam, right? And statement wise question in engineering services exam, which statements are correct. So to solve this type of questions, MSQ, everyone please read the definition, read the instructions carefully. So which are the points? Thevenins theorem states that any two-terminal linear network, this is important word, linear network, having a number of voltage or current sources, number of voltages, it may be dependent or it may be independent voltages and current sources, and resistance can be replaced by a simple equivalent circuit. Simple equivalent circuit consisting of a single voltage source in a series with a resistance. Already I have given you the diagram where the value of the voltage source is equal to the open circuit voltage, that is called VOC of the, and the resistance is equal to the equivalent resistance measured between the terminal. What is the equivalent resistance measured between the terminals? I think now you are ready to solve some questions. Yes, Dreamer, very good evening. How are you? Everyone, right? तो एक बार जरा आप लोग सेशन को लाइक जरूर कर लीजिएगा. एंड दैट इज आई एम गोइंग टू स्टार्ट विद व्हाट वेरी बेसिक ऑफ द थ्योरम्स एंड आई विल कवर बेसिक्स, moderate level and high level questions. Each and everything we will discuss in this session. It is a series where we will try to cover the complete theorems from what circuit theory. Okay, तो सब्सक्राइब कर लीजिएगा चैनल. अब देखते हैं जरा. That is the Thevenins theorem. It any linear source. This is the RL. First of all, remove the RL and find the Thevenins equivalent across A and B. This is called RTH and that is called VTH. I think now you are ready to solve some questions. So please, one question, please give me the answer within 5 seconds. Chandrasekhar, very good evening. How are you? तो अब आप देखिए जरा, बहुत ही सिंपल सा क्वेश्चन. दैट इज वेरी वेरी सिंपल क्वेश्चन, theoretical question. Thevenins theorem when applied to the DC circuit results in any type of DC circuit if we are having the DC source. In this session, I will discuss what AC also, AC and DC sources, then how to solve the DC and AC sources. Yes. So Thevenins theorem when applied to the DC circuit result in a current source alone, a voltage source alone, a current source with a resistance in parallel, a voltage source with a resistance in series. So if I am going to find the Thevenins equivalent, always remember there will be a RTH, there will be the VTH, that resistor in series with the voltage source, and that's why the option, correct option is what, like D. And yes, आप बोलेंगे सर ऐसे भी क्वेश्चंस आते हैं. Yes, in number of competitive exams, state level exams, we are getting this type of questions, but you have to give the quick response within 5 to 10 seconds. Within 5 to 10 seconds you have to give the response. Now, and that is the simple question, very very simple question. Thevenins voltage and resistance across the terminal A and B. Let this is the terminal A, this is the terminal B. Everyone, that is visible. Terminal A, terminal B. We have to find the Thevenins across A and B. This is the 5 ohm resistor, that is the 20 ohm resistor. 50 volt battery is connected here. You have the 4 option A, B, C and D. Everyone try to solve this question. I will give you the answer. What is the answer for this particular question? This is the 5 ohm, 20 ohm, 50 volt resistor. Now, how to solve this question? Okay. Now, everyone, if you want to solve this question, simply there is a one method. Just I am giving you 2 methods to solve this question. This is the 50 volt 5 ohm resistor. This is the 20 ohm resistor. Now, if you want to find the Thevenins across A and B, so everyone please take a screenshot and give me the answer. Use your rough copy, pen and calculator. Right. और थैंक यू ड्रीमर, हाउ आर यू. तो हेल्प हुआ ना. Are you getting the command over the subject? Yes. So number of lectures are available, so please go through that definitely and try to solve some questions from previous year paper as well as standard textbook. Now, if this is the VOC, already this terminal is open, means you have to calculate the voltage across what 20 ohm resistor. You can find the VOC, or that is nothing but the VTH according to voltage divide rule. 20 divided by 5 plus 20 into what is the supply here? 50. You are going to get the 40 volt. 40 volt is the answer for VTH. Now, how to find the RTH? There are two ways to find the RTH. First method. What is the R equivalent across A and B? When you want to find the RTH, first method, everyone, it is an initial class and that's why watch all the three methods. What are the three different methods to find the RTH? I am going to explain the first method, then second method and then third method. Tell me, in every method, we are going to get the same answer or different answer? RTH, we are going to get the same answer or different answer, so that you will get the idea how to apply the different methods in different circuit. Okay, in this circuit, first method, how to find the RTH? Make the Vs all independent sources is equal to 0. If all independent sources 0 means Vs tends to 0, voltage source tends to 0 means it will act as short circuit. And then there are two resistors 5 and 20. 5 and 20. And this is the terminal A and B. These two resistors are in parallel across A and B. So what is the RAB? That is nothing but RTH is equal to 5 parallel with 20. 20 into 5 divided by 20 plus 5, that is nothing but 4 ohm. So answer is what? 4 ohm. Yes, very true. Relax, AB, or yes, Abhi, and that is what 40 volt and 4 ohm. A is the option. Okay. What is the another method to solve this question? Another method to solve this question is simply another method. I am going to explain the another method. Already we have the open circuit voltage. In another method, we can find the RTH VOC upon ISC. Just I am giving you the formula. Just I am giving, because that first method is very easy method, but how to find the value? Then simply, if you have the open circuit voltage, then how to find the short circuit current? Make this terminal short circuit. First of all, put the battery here. This is the resistor. This is already here. Make this short circuit. This is the 20 ohm. This is the 5 ohm and 50 volt. This is the circuit, 50 volt. Find the short circuit current here. When I am going to find the short circuit current here, when it is short circuited, it will short circuit the 20 ohm resistor. Then what will be the current? Current will be only in this path. ISC will become 50 by 5. That is what? 10 ohm, 10 ampere. If the short circuit current is 10 ampere, what will be the RTH? VOC upon ISC. Already we have calculated the 40, current is 10, 4 ohm. That is the another method. Okay, I think this method is also clear. So, but which method is more appropriate, everyone? This is the method 2, where I am calculating the VOC or ISC. Already I have the value of the VOC, that is the 40 volt. Simply I am making it short circuit, I am getting the ISC, and then VOC upon ISC is equal to what? 4 ohm. First method, directly calculate the R equivalent at this point, and that is called RTH. These two resistors are in parallel. Third method, very simple method. In third method we are using independent sources, but we can use that method here also, dependent, but it is more appropriate with the dependent sources. For example, if I want to calculate the resistance according to third method, everyone please remember this, you have to make all the active sources tends to 0. Voltage source will act as short circuit. Remove the RL, make the RL infinite. So already there is no RL. No RL. This is the 5 ohm resistor. This is the 20 ohm resistor. Now how to find the RTH? Again the answer, we have the idea about the answer. What will be the answer? 4 ohm. Because we have the answer, we can verify. Connect a battery, external battery of V volt, or you can put 1 volt, 2 volt, 3 volt, 5 volt, any battery. Let this, the current given by this battery is I. Now this I is divided into two parts, I1 and I2. I1 and I2. And then you can find the RTH is equal to V by I. V by I, or it may be V. If you are putting the V is equal to 1 volt, it will become 1 by I. If you are putting 2 volt, it will become 2 by I. General answer is what? V by I. V by I. Then how to find the V by I? I is equal to I1 plus I2. What is the I1? This is the voltage is V. This is the reference, V by 20. Plus what is the I2? V divided by 5. You can take 20 as a LCM. It will become V plus it will become 4V. And now I is equal to V by 4. Tell me what is the V by I? V by I is equal to 1/4. So now in every numerical you can use all these three methods, but what are the limitation of this method? Always remember, if this is the third method, we are connecting the V battery, or you can connect what 1 volt battery. If suppose we are connecting the 1 volt, it will become 1 by I. If suppose you are connecting the V is equal to 2 volt, it will become 2 by 1. You can put 1 volt, 2 volt, 3 volt, 5 volt, or any volt, or general V volt. Then you will get the answer 4 ohm. Last, but one student asked me that, Surya, very good evening. One student asked me that, sir, I can connect a 1 ampere current source. How many students want this explanation? Everyone, tell me. How many students want to connect the 1 ampere current source? Yes, some student will ask, sir, I can connect 1 ampere current source. Yes, you can. If suppose you are going to connect a 1 ampere current source across A and B, then how to solve this question? Always remember, this is called method 4. Again, you have to make external source, that is independent sources, is equal to 0, that is short circuit. RL tends to infinite, already RL is not given. Connect IS, or that is like it is a 1 ampere external battery. This is the 20 ohm, this is the 5 ohm. Now always remember, if you are going to use this method, you have to find the voltage across the current source. You have to find the voltage across the current source, like this is the V. Now what is the RTH? V by I, or you are taking the I is equal to 1 ampere, means you have to find the V. V by 1, that is V. That will be the RTH. My dear friend, that is the reference, that this is the V. Write down the KCL at this point. KCL at V What is the incoming current? 1 ampere. What is the outgoing current? V minus 0 by 5. That is the outgoing current, V minus 0 by 5 plus V by 20. This is the one. I am taking the 20 as a LCM. It will become 4V plus V, right? And that is 5V by 20. So what is the V is equal to 20 by 5, that is nothing but 4 ohm. So I am using the 4 methods here. 4 methods here, okay? When I am using the 4 different methods here, right? Tell me, in every case I am going to get what? Same answer. 4 ohm, 4 ohm, 4 ohm, 4 ohm. So it depends which method is applicable. First of all, if there is no dependent sources, try to understand this concept. In this circuit, no dependent sources. No dependent sources. Right. I'm going to give you the idea that if there is no, I'm just giving you the method, which methods are applicable for which question. This is very important suggestion. No dependent sources means, for example, in this diagram, there is no dependent. Dependent means what? There are 4 types of dependent sources. Voltage controlled voltage source, voltage controlled current source, current controlled voltage source, and current controlled current source. For example, this is the shape. That is the alpha V. This is called voltage controlled voltage source. Alpha V. That is called voltage controlled current source. So this is the voltage controlled current source. This is the voltage controlled voltage source. So this type of sources, if these are not present in the circuit, only independent sources are present. Only, for example, this circuit, only independent sources are present. The method 1 is the most appropriate one. Which method? Method 1 is the most appropriate method. Means simply make the voltage source 0, find the R equivalent. This is R equivalent across the terminal. That question will become very, very easy for you. Yes, Abhi. Yes, what is your question? So do current source practically possible? No. Normally we are having the voltage source, but we can convert that voltage into current source by using what? Current mirror circuit, or by using what? Voltage to current converter. Yes, Abhi, it is clear. Practically, we have the battery of voltage source, right? Voltage source is physically realizable. Current source is not realizable. But we can convert the voltage into what? Current source. Voltage to current converter, current mirror circuit. These are the method. Okay. Now, so first, if there is no dependent sources, you can use this method. Second, what about the second method? This is the second method. VOC upon ISC. For example, in any circuit, if complete Thevenins equivalent is asked, complete Thevenins equivalent is asked. For example, in this question, VTH is required as well as RTH is required. If the VTH is required as well as the RTH is required, then you can go for this method. Right? First of all, find the VOC. Right? VOC means what? Open circuit voltage, and then find the ISC. Ultimately, you will very easily you are going to find the RTH. For example, in this question, watch this. Already we have calculated the VOC. Very easy, 40 volt according to voltage divide rule. In this question, I will make it short circuit. When it is short circuit, 20 ohm is short circuit, and I can directly say what is the ISC. ISC is nothing but 50 by 5. Directly 10 ampere. So what is the RTH? RTH will become VOC upon ISC. It will become 40 by 10, that is the 4 ohm. No need to draw the diagram. No need to draw the diagram. It is visible here. When I am making it short circuit, the 20 ohm is short circuited, and that's why the 50 divided by 5, that is the 10, is the short circuit current directly. So if the complete Thevenins is required, then you can use this method. Or if only RTH is required, you can use this method in case of independent sources only. But if the dependent sources are present in the circuit, go with this method. If you want only RTH, only RTH is required. In particular question, calculate the RTH only with dependent sources. With the dependent sources. Then you can use this method. We are applying the 1 volt battery and you have to calculate the V by I or 1 by I. Or you can use this current method with dependent sources. Okay? With the dependent sources, again, complete Thevenins or complete Nortons is required with dependent sources. I am concluding. With the dependent sources, complete Thevenins, for example VTH and RTH, both required, then you can go for VTH is equal to VOC and then RTH is equal to VOC upon ISC. Why? Because already we have the value of EOC, and that's why sometimes it will become very easy to calculate ISC. Because already we have calculated the VOC, then calculate the ISC, VOC upon ISC, it will become RTH. Right? If suppose we are going to connect what extra battery or extra current source, it will make it sometimes it will make question very lengthy for you, double calculation. And always remember, time management is also important. Accuracy plus speed, both required. You have to maintain this. Accuracy is no doubt priority. हमेशा गलत कर दोगे तो क्या फायदा है? Plus what? Speed. You have to maintain this speed. Okay. Now, so ready to solve next question? Yes, please, everyone. Give me the answer for this question. Previous year question, very simple. Thevenins equivalent voltage, VTH. You have to find the VTH, open circuit voltage, in volt rounded off to 2 decimal places of the network shown below. Now, everyone watch this question. Only VTH is asked here, but you have to find what? RTH also. Just for practice. It is a previous year question. If in any previous year question only VTH is asked, calculate the RTH also. Just for practice. Or only RTH is asked, then calculate the VTH. Thevenins equivalent voltage as well as equivalent resistance, RTH. Give me the answer of. So everyone, please give me the answer in comments box. I am going to give you some assignments also. In the last of the session, I will give you the 2 to 3 questions for assignments. Try to solve those questions. Write your answer in comments box. And definitely tomorrow I have class. So I will take a screenshot of that and I will mention the name of those students. Okay. So take it just like a challenge. Tell me. Thevenins equivalent voltage VTH for this particular diagram. Now, here it is a 4 volt 3 ohm 5 ampere current source. Always remember, it is a open circuit. Open circuit voltage means what? Open circuit voltage means the current through that particular branch is 0. Right? Watch this. This is the open circuit means. So always remember that is 0. Right? If this is 0, then what is the voltage here? What is the current through the 3 ohm resistor? 0. This 5 ampere current. So what is the path of this 5 ampere current? This is the 5 ampere current. And the voltage at this point is VOC. Voltage across this 5 ampere voltage source is what? VOC. Now this 5 ampere current will flow like this. This is a 4 volt. Right? So what is the, it is connected in a parallel. So what is the voltage at this point, everyone? 4 volt. I have the current, I have the voltage at this point. We can simply find the VOC. is equal to, at this point it is a VOC. Write down the KVL from this point to this point. Always remember, already we have the voltage at this point 4 volt. So write down the KVL. VOC is equal to 5 into 2 plus 4. 14 volt. How many students are giving the answer? Yes, Ram Krishna, your answer is correct. 14 volt. Very simple question. Very simple question. Right? Now, try to understand this concept. This 5 ampere current will pass here. What is the current through the 3 ohm resistor? 0. This is 0. Now, at this point, if suppose I am connecting a 3 ohm parallel to 4 volt, you can remove this 3 ohm resistor because the voltage will remain same. What is the value of this resistor? It doesn't matter. The voltage at this point will remain the 4 volt because it is connected in parallel. Write down the case KVL. VOC is equal to 5 into 2 plus 4. I think this question is clear. That is what 14 volt. Now, how to find the RTH? Because only independent sources, make it short circuit, make it open circuit. Make it short circuit, make it open circuit, because only independent sources are here. Very simple question. RTH is required. Then, when I am making it short circuit, 3 ohm is short circuited. Already it is short circuited, no need to consider. 2 and this is the 3. And this current source will act as open circuit. So what is the RTH here? What is the RTH? R equivalent. Five ohm. 5 ohm is the RTH. Yes, bilkul sahi Ram Krishna, your answer is correct. Abhi your answer is also correct, and that is the very simple question. Right, so that is the answer. Okay, then next question. Next one. No. In the circuit shown below, the Thevenin's voltage, only VTH is asked. Again, VTH. Give me the fast response. Give me the fast response for this question. Only independent sources. 2 ampere, 2. This is the 1 ampere current source, 1 ohm. This is the 2 volt. Now, if the VTH is asked here, always remember, open circuit voltage means this current is equal to 0. What is the VTH? This is the VTH here. This is the VTH here. Now, this is a 1 ohm resistor. Remember that this is the 1 ampere current source, and that is the parallel with the 1 ohm resistor. You can convert it into what? A voltage source. You can convert it into a voltage source. You can apply the source transformation. If you are going to apply the source transformation, this question will become very easy, right? Remember that. Everyone give me the answer for this question. 1 into 1, that is 1 into 1, 1 volt. In series, 1 ohm resistor. That is called source transformation. That is the 2 and volt. This is what is the polarity? This is the polarity of 2 volt. This is the 2 ohm resistor. Now, no need to change it. If you want to change, okay. Otherwise, no need to change this voltage source or current source. You can directly apply, or you can also change 2 into 2, that is the 4. And in series, this is the 4 volt and this is the 2 ohm. This is the 4 ohm, and we want VTH here, open circuit voltage here. This is nothing but VTH here, because what is the current through this? 0. VTH. Now this is the 4, this is the 1, and this is the what? 2. 2 and 1 are in series, and 1 and 2 ohm are in series. That is the total 3 ohm. Write down the KCL at VTH. KCL at VTH. VTH minus 3. 2 plus 1, 3. Divided by 2 plus 1, 3. Plus VTH minus 4. VTH minus 4 divided by 2. is equal to 0, because what is the current in this branch? 0. Now you can take the 6 as a LCM. It will become 2 VTH minus 6 plus 3 VTH minus 12 is equal to 0. 18, and that is the 5. So VTH, 5 VTH is equal to 18. If the 5 VTH is equal to 18, what is the VTH is equal to 18 divided by 5? That is nothing but 3.6. So remember that all your VTH you are giving Ramakrishna 9 volt. How is it possible? Remember, आंसर में देखो नहीं है 1 2 3 4. आप बोल रहे हो नन ऑफ दिस नोटा, मुझे कोई भी पसंद नहीं आ रहा है. Okay, no problem. Right, watch this. If I am going to calculate in a systematic way, I am converting this voltage source in current source into a voltage source, so that I have to apply the KCL at only one node. Otherwise you have to apply the KCL at 2 nodes. You can also consider the voltage at this point V1, and then you have to apply the KCL at this point and that point. You can find the value of the VTH, right? But if I am converting into source transformation 1 volt, this is the 1, these two are in series, 2 plus 1 3, and this 3 are 3, this is the 4 volt. You have to apply the KCL at only this point. This is called nodal analysis. VTH minus 3, 2 plus 1 3 upon 3 plus VTH minus 4 upon 2, that is equal to 0, and then you can find the value of VTH. Easy? Yes. Now if in this question, if you want to find what? If in this question you want to find the value of RTH, very simple. Make it open circuit, make it short circuit, make it open circuit, and it will become very, very easy for you. Very, very easy for you always, whether it is asked or not, but simply open circuit. Because in exam hall normally we can make the silly mistakes. Short circuit, this is the 1 ohm, this is the 2 ohm, this is the short circuit, this is open circuit, this is the 2 ohm, that is the 4 ohm. And you have to find the Thevenins across A and B, that is the 2 ohm. These 2 plus 1 3 and 2 are in parallel, 4 ohm in series. So RTH is equal to, watch this, 4 ohm plus 2 parallel with 3. You can find the value. That is 1.2, 5.2 ohm. 5.2 ohm, that is the answer for RTH. Okay, easy? Right. Yes, this is the 26 by 5, or simply we can say 5.2. 5.2 ohm. Okay then, तो ये हो गई इसकी बात. Now next question. So that is I will solve one as with dependent source, but first of all this is the assignment for you. Everyone write the answer on what comments box. Okay, subscribe our channel, share the link of this session, और अपनी अटेंडेंस तो देना है, तो लाइक तो कर ही दीजिए इस सेशन को. यस और नो. लाइक करने का मतलब है यू वांट दिस टाइप ऑफ सेशंस. एंड इफ यू हैव एनी क्वेश्चंस, टिपिकल क्वेश्चंस फ्रॉम थ्योरम्स, then please post those questions in my telegram channel, that is electronics by Sanjay Rathi. Definitely in next session I will try to cover those questions. Okay, so now this is the assignment. Abhi session baki, I will solve the question on dependent source also. So that is the assignment. Only independent sources. This is the input Vi, 1 ohm, 5 ohm volt, that is the 1 ohm. The resistance are looking into the terminal A and B. This is the terminal A and B, right? And this is the Vi, what will be the resistance. This is the value VCD. You have to find the value here. Second question. Now this is the question on what dependent sources. I am going to solve this question. Yes, Consider the circuit shown in the figure, the Thevenins equivalent voltage across the A and B. Right? You have to find the voltage across A and B, and there are two dependent sources. This is the 0.1 I naught. Where is the I naught? This is the I naught. 0.1 I naught. This is the V naught. And you have to find, this is the 2 V naught, this is the voltage across, this is the V naught, and that is the dependent sources 2 V naught. Now, you have to find the Thevenins across VAB, that is the VTH. This is called open circuit voltage across A and B. Okay. Then remember that this is like you can assume as a reference node, like this is the 0. Then these are short circuited. These are the short circuited. Then you can assume one single node Vx and then Vx. And this is become what? VOC. That is nothing but VTH. Now we have the two unknowns in this diagram. What are the unknowns? VOC and Vx. And then you can find the value of VOC. Right? I am just giving you the very simple method. Then we can solve by using the different methods. Right, watch this. Once you want to find, remember that what is the I naught? Always remember, first of all, what is the I naught in terms of Vx, because we have to find the two unknowns Vx and VOC. Vx minus 0, like watch this. This is the voltage I am assuming that Vx minus VOC is equal to I naught, or simply I can say Vx is equal to 20 I naught. Vx is equal to 20 times of I naught. Vx by 20. Okay, no issue. Then what is the V naught here? V naught is nothing but VOC minus Vx. V naught is equal to open circuit voltage minus V. And what is the Vx is equal to 20 I naught. Now that is the equation number 2. Okay. Then simply apply the KCL at this point. What is the incoming current at this point? 0. I naught. KCL at VOC. What is the incoming current? 0.1 I naught is equal to, what is the outgoing current? At this point the current is 0 because it is an open circuit. So VOC minus Vx upon 10. That is nothing but V naught upon 10. And you can write upon 10. You can write VOC minus Vx is equal to, when I am multiplying it with this 10, it will become I naught. VOC minus Vx is equal to I naught because it is multiplied with the 10. This is the I naught. You can use this formula here. VOC minus Vx is replaced by what? I naught, and you will get the result V naught is equal to I naught. Yes or no? From these two equations, you are going to get the I naught is nothing but V naught. Okay. Now write down the KCL at this point. How to write the KCL at this point? That is very, very important. When I am considering these two nodes simultaneously, I am writing, that is called what? Supernodal analysis. And what is the difference between these two nodes? What is the difference between the voltage between these two nodes? 0. So I am going to write Vx. What is the outgoing current? Remember that 0.1 V naught. Outgoing current 0.1 I naught. Sorry, V naught and I naught are equal, and that's why I am writing this. Plus Vx minus 2 V naught upon what? 40 plus, now Vx, this is the outgoing current, this is the outgoing current, Vx minus 2 V naught upon 40 plus Vx minus VOC upon 10 plus Vx upon 20, that is nothing but I naught. What is the VOC minus Vx? VOC minus Vx is equal to I naught. You can replace this You can replace this, you can replace this, and you are going to find the value of this. So how many students are? That is the way how to write the equation here. Now there are two unknowns. One unknown is what? VOC. One unknown is what? Vx. Then that is the role of what? All the dependent sources. First of all, my dear friends, I am just giving you the very simple method, right? Because we are having the relation, right? First of all, replace this I naught in terms of V naught. You are going to get the value of V naught, and then simply you can solve this question. But what about this method? Is it easy or tough? Right. अगर आप बोलेंगे सर यस थोड़ा सा तो टफ है, तो मैं आपको बताता हूँ एक और इजी मेथड जिसको आप लोग सॉल्व कर लीजिएगा. 1 minute. Watch this. Another method. Let this current is I1. Let this current is I1 and let this current is I2. From the diagram, you are directly going to get the I1 is equal to 0.1 I naught. I naught. Okay. And what is the I2? Because there is no current here, I can say the I2 is equal to I naught. I2 is equal to I naught. This is the first, this is the second. Now what is the VTH here? Write down the KVL here. When I am writing the KVL, the current in the downward direction is I1, current in the downward direction is I2. I can write the KVL here. So what is the VTH is equal to? VOC is equal to 10 times of I1 plus 10 times of I1 plus 20 times of I naught. That is nothing but 20 times of I2. That is the equation number 3. Okay. Now from this you are going to get V naught is equal to 10 I1. V naught is equal to 10 I1, and you have the idea what is I1 is equal to 0.1 I naught. When I am putting the 0.1 I naught here, it will become I naught. Already we have this equation from the previous question. Now write down the KVL. Always remember, we can't write the KVL by considering the current source. Simply write down the KVL. When I am writing the KVL, it will become 20 times of I naught minus 2 V naught plus 20 times of I2. This is the 20 times of I2 is equal to 0. Now what is the I2? I2 is nothing but I naught. What is the V naught? I naught. What is the I2? I naught. Is equal to 0. From this you are going to get everything is in terms of what I naught. So what this condition is satisfied only when the I naught is equal to what? 0. I naught is equal to 0. So remember this equations, because everything, watch this, is there is anything is missing? No. 20, when I am writing the 20 I naught, that is again minus 2 V naught, that is again 20 I2, that is again 20 I naught minus 2 I naught, V naught is replaced by what? I naught, 20 I naught, and this equation is satisfied, right? Watch this. I naught is equal to 20 plus 20, 40 minus 2, 38 I naught is equal to 0, means I naught is what? If the I naught is 0, means I2 is 0, I1 is also 0. What is the value of the VTH? You can find the value. This is the VTH. Yes. What is line X? What is your question, sir? June I will complete my all subjects for GATE, or after that for July if I consider. Okay. No. If you are going to complete that up to June, you are going to complete all the subjects. That is very good. And if you want to solve the questions, then go for what quizzes, go for what mock test, and daily 3 hours revision, short notes and detailed notes, then more than sufficient. Okay. But hota na effective hours. What are the? These are the effective hours. 3 hours per day. Effectively, you have to give the effective 3 hours, but you have to give the mock test. Okay then. So this is the question. Now I am going to give you what some important assignments. Please check my calculation, but that is the method, my dear. In this question we are applying what KCL or nodal analysis, but in this question we are applying what mesh analysis, right? And this, because of this mesh analysis, that question will become very easy. Always remember, don't worry about the dependent sources. In tomorrow I will solve all these questions. Try to give me the answer for this question. Yes, that is the assignment for you. Give me the answer. What is the answer? This is the assignment number 2. Give me the answer on the comments box. This is very simple question. Assignment number 3. Then assignment number 4. And this is the assignment number 5. So try to solve all these 5 questions. If always remember, if in any numerical Norton's resistance is written, don't worry. Same Thevenins and Norton's resistance are equivalent. In tomorrow's session, I am going to explain what Norton's theorem also. Right? So try to solve this type of questions. You are on BYJU'S Exam Prep, and please give me the comments which type of topics you want here. Write in comments box, and simply like the session, subscribe our channel, right, and share the link of this session. Thank you for attending the session. Please note the time, daily 8 PM. Complete theorems with numericals with previous year questions. Okay then, thank you and good night.